Hello everyone, I am Jaydevan, the one who developed the rain rule VJD method, an alternative to the Duckworth and Lewis system in limited over cricket matches. As everyone knows, the DL system, now it is called DLS system, has completed 25 years of its use in the international cricket. Each and every version of the DL system has so many anomalies. Every version of VJD method was actually better than the corresponding version of the DLS DL system. BCCI is using VJD method for nearly 17 years in the Indian domestic cricket, and umpires and scorers are quite happy with it. But still, it is yet to be used in IPL. Under these circumstances, I have taken an important decision that there is no point in just carrying on with VJD method alone, and it will be better if I can rectify the anomalies of the DLS system. Since I know DL system for the past 25 years and studied it very closely, I felt that I would be one of the better persons to rectify its mistakes. Now I am doing this video to share with you one important news, that I have successfully rectified all the anomalies which I have been pointing out. Right from the very first version of DL system, which was implemented first in 1998, to the latest version DLS 5.0 2022, the different versions of the system have a lot of anomalies. Especially the version WinCoda 2.0, used for 2 years including 2011 World Cup, was in fact a bunch of jokes and was not even qualified to use for school cricket. But even that survived for 2 years at the international level. However, the video will be too lengthy if I try to cover all those aspects, and hence here the discussion will be confined to the anomalies of the latest version, that is DLS 5.0 2022, and even there I am just pointing out only a couple of examples, otherwise the video will be too lengthy. In a match, say a 50-over match, when a team starts batting, saving wickets is also equally important as scoring runs. Just consider two cases. One, all wickets are intact at the time of interruption. Two, lost 2 wickets. If losing 2 wickets takes place in the beginning, that is say before 5 overs, it will seriously affect the team's performance. But if it happens by the 20th over or so, then still it will have a considerable impact, but much lesser than what it would have been in the previous case. And if it happens say by the 40th over, then it will have hardly any impact, because whether you have all 10 wickets in hand or you have only 8 wickets in hand, the remaining overs are just 10, and that is more than sufficient to utilize the remaining 10 overs. This is a basic principle, and it is valid irrespective of a team's score. Now let us consider a case where the interruption is occurring while team 1 is batting and their innings gets terminated, and then team 2 also getting same number of overs. So I am considering 3 stages. 1, interruption at 20 overs. 2, interruption at 27 overs and 3 interruption at 35 overs. After the interruption, team 1's innings gets terminated and team 2 also gets same number of overs. At each stage, the difference in targets set for team 2 when team 1 hasn't lost any wicket and 2 has lost 2 wickets is found out for 3 scores. 3 scores means 70, 90 and 110. So, as per the principle we discussed, the difference in targets should be maximum for the stage 20 overs and it should be minimum for 35 overs, and for 27 overs it should be in between, because if the team loses 2 wickets by 20 overs, it will have considerable effect. But if the team loses 2 wickets by only 35 overs, it will not have much effect, and if it is by 27 overs, it will be in between. Okay, with this idea in mind, now let us go to the table. Now see this table. Here I have taken interruptions at 3 stages, 20, 27 and 35, and team 1's score is 70 runs. So for 70 for 0, the target for team 2 is 159, and for 70 for 2, the target is 127, and the difference is 32. Of course, here this target looks very high, but since that's a different issue, we are not taking it up at this time. We are actually trying to discuss something else. So this is okay, 32. Now if the interruption occurs when 27 overs are completed, the targets are 145 for 0 wickets and 122 for 2 wickets, and the difference is 23 runs. So it is coming down nicely. And if the interruption takes place after 35 overs, the difference is 113 minus 106 is equal to 7. So again nicely it is coming down. So this is following the right pattern. So there are no issues with this score of 70. Now let us see if the score is increased to 90 from 70. If the score increased to 90, what happens? If the interruption is taking place at 20 overs, again the targets are 174 for 0 wickets and 155 for 2 wickets, and the difference is 19, and this also is okay. But if the interruption is taking place after 27 overs, you can see the target is suddenly shooting up. Here in the previous case it was 145 only, and just for 20 runs increase in team 1's score, that is from 70 to 90, the target is increased to 185, and that is why a huge difference you can see here, 29 runs. So as per the principle which we have discussed, this value cannot be more than this value. This value cannot be more than 19. But it is not just high, it is 10 runs high. That means a big difference is there. So this is a big blunder. This happens only because of this value. So this target is totally wrong. Say now if somebody says that no, for 20 runs difference you can have 40 runs difference in target. Okay, if somebody is saying that, I will ask them to look at the next increase. Now from 90 to 110, if you give another 20 runs increase, you can see that the target is increasing to 201. That means the difference is only 16 runs. That means for the first 20 runs increase from 70 to 90, the target is increased by 40 runs, and the subsequent increase of 20 runs, the target is increased only by 16 runs. So that reveals that this value is a big blunder, Okay. Now, but if you see the increase for this score, that means if the score is 110, again it is correctly maintaining that pattern, because for 20 overs it is more, 27 overs it is less, and for 35 overs it is still less. But of course you can see after 35 overs the difference should have been much less. Here you can see nicely it is coming down from 22 to 14, but here it is coming down only by 3 runs. That also is a mistake, though the pattern is maintained. This value should have been just 4 or 5. So that is a mistake. But anyway, we can that's a small mistake actually compared to this big blunder. Now let us see how the proposed method DLJ, I am calling it DLJ method, how the proposed method behaves under these conditions. Here again, for 70 runs, you can see for 70 runs for 0 wicket and 2 wickets, the targets are 144 and 118, and the difference is 26 runs. And if it occurs at 27 overs, the targets are 135 and 121, and the difference is 14. And if it occurs at 35 overs, it is 116 and 112, and the difference is 4. So very nicely, you can see very nice and smooth variation, and it is in the right order. Okay, now let us go to 90, the score 90. Here also, if the interruption takes place after 20 overs, the targets are 168 and 141, and the difference is 27. And here, if it takes place at 27 overs, the targets are 165. Here you can see it is 165, and in case of DLS system, this value was 185. That is why it gave a very big blunder there. So here 165 minus 148, 17. So nicely coming down. Here also for 35, again it is 4. So here also smooth and nice variation you can see. And if it is 110, the score is further increased by 20 runs. You can see that here in case of interruption taking place after 20 overs, the difference is 27. Now for 27 overs it is 19, and for 35 overs it is 5. So very smoothly it is coming down. So this one example itself will reveal that this system, this is a little bit complicated example because 2-3 cases we are considering, but to prove the anomaly of the DLS system, that is essential. That is why I chose such an example, but it is very clear from this example that DLJ system is much superior to the DLS system. Now I will show you a small example also. Okay, actually this is sufficient enough but if somebody has got confused since I have shown so many numbers, I will show you a very small example also. This is a case, again the interruption is taking place while team 1 is batting, and the interruption is taking place when team 1 is at 60 for 0 in 20 overs. 60 for 0 in 20 overs. And the target set by DLS system is 152 runs. You can see it's a huge number, 150 runs. For every run team 1 has scored, team 2 has to score 2.5 runs. Okay, just forget about that. Now let us see what is the target if instead of 0 they have lost 2 wickets. The target is just dropping down to 109 runs. Of course 109 is a very reasonable value, no doubt about that. But this difference, if you see the difference is 43 runs, 152 minus 143 runs. Okay, now if team 1 has scored 90 runs, instead of 60, if team 1 has scored 90 runs, the target is increased to 174. That means from 152 to 174, that means only 22 runs. For 30 runs increase here, only 22 runs increase in target. Okay, but if you take the other case, that case means if the team has lost 2 wickets, okay, then how much increase will be there in the target? Earlier it was 109. And for 90 for 0, it is just shooting up to 155. That means 46 runs difference. Here only 22 runs difference when no wickets are lost, and 46 runs difference when 2 wickets are lost. And people are saying that this system is mathematically sound, and I feel that this is really funny mathematics. But let's just have a look at how the proposed system behaves under this condition. For 60 for 0, the target is 129, and for 60 for 2, the target is 105 runs. Okay. When the score is increased to 90, the targets are 168 and 141 respectively. That means an increase of 39 runs in this case. 39 runs, 168 minus 129. So 39 runs in this case. This case means when no wickets are lost, and when 2 wickets are lost, it is 141 minus 105 is equal to 36. Almost the same. 39 and 36, almost the same. So it has to be like that only. So, this example also clearly reveals that the proposed method is much more sensible than the method used by ICC. This is a major breakthrough. Messrs. Duckworth and Lewis, and after that Stephen Stern, were trying to rectify these anomalies for the past 25 years or more, and they could not do it. Actually, the VJD system I have developed also was free from all these anomalies, but ICC did not give it the deserving consideration. It is the obligation of the ICC to provide the best available tools to the cricket community. The proposed DLJ method is far superior to the DLS systems. I have sent this proposal to BCCI and ICC, and in which I have illustrated a few more examples to show the flaws of DL system. Let us hope that they will consider it positively this time. If you find this video worth watching, please share it with all cricket lovers. Thank you.